Welcome back. Problem number 17, letters combination of a phone number. So, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent, and we should return the answer in any order. It doesn't have a specific order for this problem. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any other letters. Okay. So first, let's try to understand the problem. So you have a string made up of digits where each digit corresponds to a set of letters, just like the button that you can see here, as an old mobile phone. I don't know if one of you used like a phone like that, but if you wanna hit C, you should have to press number 2 3 times to order to have the C letters. So if we have 2 letters, we have 2 and 3. What are the possible combinations that we can create? It's basically we can create AD, AE, AF, and BD, BE, BF, CD, CE, CF. Yeah, etc. So it's basically we want to calculate all the possible paths, all the possible string, all the possible combinations from these 2 digits. And there is a keyword that you can find when we have any problem that has all possible solution, all possible paths, all possible numbers, all possible anything. You should first think with using a backtracking approach, using a recursive function that will try all the paths for you, and after that will return for you the final result, instead of creating inner loops that so you will not present a solution which has like of n square or something. So to solve this problem, we use a technique called backtracking. This is like trying out all possible paths to find all solution, and then going back, which is back, because that we call it backtracking, when you reach the end of one path to try out the other one. So how we will do that? First, let's just try to create a variable I will call the combination, and it will equals an empty array. And I will create a map. I'll just copy this one here because it will not look, it doesn't make sense to just try to write everything here. So first we just have mapping to digits here, which just first we need a way to know which letters each digit corresponds to. So we use a map for this. So a map is like a directory that pairs keys, like in this case, digits, for example, in this case, are digits. The keys are digits with values, and in this case, the values are the string. So digit number 2 will have these strings, and digit number 3 will have these strings, etc. It's important to know that that digit's length can be from 0 to 4. So if it's equal or bigger than 0, we have an edge case. We need to make sure if the digit's length is 0, we have no combination letters. That means we return this array. So if the digits length equals 0, we return the combination, which will be empty array. We can return an empty array, like we can do both. I guess right now we could start in the backtracking function, and the core of the solution is recursive functions, and we call it backtrack. This function tries to build all possible combinations by picking one letter at a time from each digit and adding it to the current combination path. So let's see how this will work. So I will create a function. I will call it backtrack. Let's just go here, and we have a function called backtrack, and it will have index and also a path. And first, okay, this is a recursive function. When you have a recursive function, the first thing that we should think about is a base case for, and in this base case, where we will stop calling this function, because a recursive function is just a function that it will call itself over and over and over, and we need to give it a base case that when the function reaches this base case, it will stop executing. So let's think about the base case. The base case should be if the current path length is equals to the digits length, because that we cannot continue. So I would say if path dot length equals digits or phone digits dot length is index, and path length is equals to oh, wait a minute, I guess I need to create a variable. I will call it phone digits, and it will equals digits, because we don't want to change that. And if phone digits dot length, so if we change it in digits, we'll not get any problem. So we have phone digits dot length. In this one, if that was the case, basically we put combination dot push, we put the last thing. There is a problem here. I can see what is it. Wait a minute. Oh, yeah, there is a problem. Yeah, combination dot push, and we just put the path, and we return nothing. Okay, so we have our base case right now. After that, we need to get the possible letters for the current digits. So how we do that? Const possible, I guess I just mispronounce it. No, possible letters, which will equals letters. I guess I need to create a letters letters. Yeah, the letters map, which will equals no. Letters we can get from the map dot get phone digits dot the character at the index, and by this one we get the possible letters. Okay, and we will loop through that because we got an array of strings, a string, so we loop through this array, through this string. So for const letter of possible letters, we will we have const new path, which will equals path plus L, and we set the path plus L, and it's a recursive function, so we call the function here again, and the path will be the index. The index will be index plus 1, and the path will be the new path. And at the end, we will call the backtracking function with 0 and empty array, and we should return the combination. And I will try to describe everything right now because recursive is not easy. So okay, let's just recap the backtrack. Let's just first submit the code and see if it works or not. Okay, it works. Okay, that's great. So first, in the backtracking, the core of the solution is to recursive function called backtrack, And this function tries to build all possible combinations by picking one letter at a time from each digit and adding it to the current combinations. How it works: first we start with the first digit, get its corresponding letters, as you can see here, and to try each one. Like for each letter, we add to it the current combination and move to the next digits. If we have added as many letters as there are digits, we have a complete combination which we then save. After that, we backtrack, meaning we remove the last letters and try the next ones. So this is how it works. And in this one here, we start the backtracking process by calling backtrack 0 and have a empty strings. And the 0 is a starting index, which is the first digits, and empty string is a starting path, which is an empty path. So as you can see here, this is all the magic happens in these 3 lines. First, we get all the possible letters we got from this map, and after that, we loop through this string, and for each character or for each letter, we basically create a new path, and we call the backtrack again, and over until we reach the limit, which the path.length equals the phone digits.length. So if that was the case, we just end this recursive function, and that's it. It's as simple as that. So I would say recursive problems are not easy to understand. Also, they're not that easy for me to describe and solve. So just take your time, and if you have anything that you don't understand from my solution, just feel free to ask me. So that's it for this one, and see you in the future.